of Kids Science Club, Madrasty Kids Science Club. My name is Jamana Tariq Abdulrazak. I'm studying for a master's degree in petroleum engineering at University of Houston, and I will be your podcaster this afternoon. These sessions will introduce different topics in science, each week a different topic for children aged 10 and up. Attendance will be followed by tests with a passing score of 70%. If achieved, the participant will get a certificate. We're still accepting young future scientists in this program, so if you're interested, make sure to apply before the deadline. If you haven't already, please make sure to check out our YouTube channel and join our Facebook page, Madrasty, for the latest updates on our upcoming courses. That I ask you to give your full attention in the podcast. In this first episode, we will give an introduction about basic physical parameters and their importance to our beloved home, Earth. Today, we're pleased to welcome our future young scientists, Yusuf, Saif, Julie, Tuta, and Basil. Please allow my fellow podcaster, Mariam Sharif, to introduce herself.
My name is Mariam Sharif. I'm from Lebanon and I'm a petroleum engineer, and I'm happy to be with you here today.
We're happy to have you with us. Now, future scientists, please introduce yourself. We'll start with Yusuf.
All right. My name is Yusuf. I'm 13 and taking freshman classes in high school, and I'm happy to be here.
Thank you. Now, Saif.
Hi, I'm Saif. I'm 14 and I'm a freshman in high school, and I'm glad to be here.
Thank you. Jolie.
Hi, my name is Jolie. I'm in third grade and I'm 9 and I'm happy to be here.
Thank you. Basil.
Hi, I'm Basil. I'm in grade 5 and I'm 10 years old, and I'm really glad to be here.
Thank you. Tuta.
Hi, I'm Tuta. I'm 15 years old. I'm 8th grade and I'm really excited to be here.
Thank you. Are the future scientists ready to rule the world?
Yeah.
Yes? No?
Yeah.
Okay. Here we go. First definition.
So are you excited to start?
Mm-hmm.
So
Yeah.
the first question is that, what do you know about gravity? So can you define gravity? We can start with Yusuf.
All right. So gravity is an invisible force that pulls objects toward each other. Earth's gravity is what keeps you on the ground and what makes things fall. Gravity also gets weaker with distance.
Safe?
Yeah.
So-
Anyway, gravity is the force of attraction between all matter.
Yes. Julie, do you want to add something?
Yeah, gravity is a force which keeps everything on the ground.
Yes. Tuta?
And there's an apple drawn here because Isaac Newton, the one who discovered gravity, had an apple farm instead. So he wondered why the apple fell to the ground. So he did some research and found out that there's a force, which we now call gravity, that's attracted to the ground.
Exactly. And finally, Basil, do you want to add something?
Oh yeah. First of all, gravity, yes, it's pulled us, always pulls us to Earth, and it pulls the Earth together. Without gravity, the Earth would just be chunks of ground and nothing holding it together. Gravity is what makes it a sphere anyway, because the sphere is always pulled equally from every point of it. If you go to north, south, east, west, anywhere, and we're always pulled to the bottom side of the Earth. If we're maybe in the north, we're pulled to the south. If we're in the west, we're pulled to the east. We're pulled to the other side of the Earth.
You're pulled, yes, but I want to add something. You're pulled to the core of the Earth, not the opposite side. So gravity is the force that attracts a body towards the center of the Earth, and it's as you said, it's discovered by Newton. Now, can you tell me what is the relationship between gravity and other planets? Safe, do you know?
Yeah, planets with a higher amount of mass will have a higher gravitational pull. Also, I think the people who are watching want to answer the questions too.
Yes. Yusuf, do you want to add something? You're muted.
Sorry, no, Dad.
Julie,
I have nothing to add too.
Tuta, and Basil.
Oh, nothing.
Yes, so as Saif said, gravity is what holds planets in orbit around the sun, and it keeps the moon in orbit around the Earth. Now we'll be moving to the second question.
Next, we have force. What do you guys know about force? We'll start with Yusuf.
Okay, a force is a push or a pull. Forces can make things move, change their speed, or change their shape. Some forces act when two things touch. For example, when a person kicks a soccer ball. Other forces act over a distance, such as the pull of gravity or a magnet pulling a piece of metal.
Great answer. Now, Saif, I have a question for you. What's
Okay.
the direction of gravity?
Towards the largest source of mass, or towards any source of mass.
That's right. In our case, on Earth, gravity is towards the center of the Earth. Basil, is there something you'd like to add?
Yes. By the way, gravity is a kind of force. Since it pushes us, and since a force is a push or pull, it pulls us to the core. So gravity is the force.
Awesome. Tuta?
No, I have nothing to add.
Julie, is there something you'd like to add?
No.
Great. Now we'll move to the next definition.
So what do you know about friction? So can someone define friction to me? We can start with Tuta.
Well, friction, an example of friction is when I rub my hands together. This friction produces heat. So friction is when two things touch each other. Like when we're walking, we need friction so we don't slip. So like if you're walking, the friction is between your legs and the ground.
Exactly.
If the ground is smooth, then there will be less friction, and if it like has bumps or something, then there will be more friction. So it will be hard to walk.
Exactly. Yusuf, do you want to add something?
No, thanks. I'm good.
Julie?
No.
Safe?
Friction keeps planes in the air because, well, lift is basically where the wings have a certain amount of friction against air molecules that allow lift to occur.
Excellent. Basil?
And by the way, friction is also used in light bulbs. So when energy moves in the wire, well, and also in fuses, by the way, the fuse makes when there's too much energy, it makes too much friction, so that the heat burns down the metal wire, so it saves the device.
So can you tell me how can we reduce friction? What material or a substance that can be added that help us to reduce friction?
if you want to reduce friction in a motor or an axle of a wheel in a car, you can add oil or just make it smoother. If it's kind of like jagged or like kind of rough, you can smooth it out so it moves faster. Or you can just add some oil.
Yes, so we can use lubricants and oil, any type of oil to reduce friction. True. So moving to the fourth question.
Now we're moving to the sound. What do you guys know about the sound? We'll start with Yusuf.
All right. Sound is created when something vibrates and send waves of energy, such as sound energy, into our ears. The vibrations travel through the air or another medium, such as solid, liquids, or gases, to the ear.
Awesome. Now, Saif, is there something you'd like to add?
Sound travels at 343 meters per second through 20 degrees Celsius air.
Great. Julie, something you'd like to add?
No.
Basit, I have a question for you. Why does space have no sound?
It has no sound because there's the vacuum. Sound already only moves to our ears because the vibration of the sound moves through the air and moves the particles. So the particles keep moving until it comes to our ear, so we hear it. Like in this mini guitar I made, we get a plastic box and we get an elastic rubber band. When we stretch it, it makes a vibration that we can't even see it. Look. And made a sound.
Impressive answer.
Thanks.
Tuta?
Oh, can I say something else?
Yes, please go ahead.
The stronger the pull, the louder sound it makes. And if you make a smooth pull.
Great. Tuta, is there something you'd like to add?
Nothing.
Moving to the next, magnet.
So tell me, what do you know about magnet? What is basically a magnet? We can start with Saif.
Okay. So magnets use electromagnetic force to pull ferromagnets or ferromagnetic objects. And it does not have to contact the other item in order to pull it. It can pull it from a range.
Yes, exactly. Yusuf, do you want to add something?
No, thanks.
Julie?
No, thank you.
Tuta?
Well, magnets have north and south poles, like this one I have here. If you get a south pole and north pole, they're gonna attract each other. But if you get a south pole and south pole, or a north pole and north pole, they'll repel each other.
Exactly. Excellent. Basil, do you want to add something?
Oh, I just want to add something on to the words, by the way. Like poles repel each other, but different ones attract.
True. So as you all said, a magnet is an object capable of producing a magnetic field, attracting unlike poles and repelling like poles, as Basil said. Now moving to the next question.
Oh, can I say something? Important part?
Yes, please go ahead.
The Earth's core has iron and cobalt, and iron and cobalt are like magnets. They're what make they're the things that make magnets. They're the most important part in it. There's actually iron. So it's actually if you tie a rope to a magnet and leave it to move through, you will find the north part, but you have to use a bar magnet, by the way. You'll find the north section pointed to the north, and the south section pointed to the.
Exactly. So these metals are referred to as ferromagnetics, magnetic metals such as iron, nickel, as you said, and they are attracted to magnets. Excellent explanation, Basil. So we can now move to the second question, to the next question.
Somebody asked a question in the Q&A section. He says that when magnet has no effect. Magnet has no effect when both
It's okay. We'll keep track of a Q&A section. But great answer, Basil. Now we'll move to the next question here. Distance. What do you guys know about distance? We'll start with Jolie this time.
Distance is how far one thing is from another thing. It is also a measure of the space between two things.
Great, impressive answer. Yusuf, is there something you'd like to add?
No, that practically sums it up.
Safe, something you'd like to add?
Well, distance can be measured by a time or like actual, space. So like a light year is measured in the amount of time it takes light to move a year. So it's an amount of time. It's measured by time. But something like a mile is measured by a certain length or a certain amount of feet, which is a certain distance in itself. So.
Sure, so Bessie?
And by the way, distance can be measured by the metric system. You can measure it like with millimeters, centimeters, meters, kilometers, and it can also be measured like with pretty much anything. You can maybe use your finger. Maybe your laptop is 10 fingers long, maybe. Or you can say it's also 2 boxes long. You can measure those pretty much anything. You can make it your own kind of measuring system.
Great answer, Tuta.
I was going to say chasing. I haven't looked at it.
Okay, now we'll move to the next question.
So what do you know about energy? So Julie, can you tell me?
The next question. I would just like to add that distance is the amount of space between 2 points, whether these are things, people, or labs and arrays, rounds, whatever it is. It's distance between 2 points. Now moving to the next question with Nadia, energy.
So tell me, what do you know about energy? So Julie, can you define energy?
Energy is the ability to do work, and energy is how things can change and move.
Yes, exactly. Yusuf?
I have nothing to add.
Yes, but I want to add something. Energy is we can transfer energy from one state to another. So yes. So we can move to Safe.
There are many different states of it or types of energy. You have, heat energy, you have chemical energy, and they're all produced from different sources.
Exactly. Basil?
Oh, there's also kinetic energy and light energy and some more. And you can change them from one to another. Like maybe an chemical power to light power. You can light energy. If you use the chemical energy and you use a wire to make a circuit to a light bulb, it will glow.
Yes, so here Basil, he's trying to explain about the law of conservation of energy. So energy is not created nor destroyed, it's conserved. So it can be changed from one state to another, as Basil explained. Tuta, do you want to add something?
Yeah, I can say that there are a lot of kinds of energy, like potential energy. That's when like the thing moves. Kinetic energy is when it moves. There's also thermal, chemical, nuclear, and other stuff.
Exactly. So as you said, energy is the capacity to do work, as Julie said. And we have several types of energy: thermal energy, kinetic, potential, or electronic energy, and also nuclear. And energy is usually measured in joules. So moving to the next question, please.
Next question, heat transfer. What do you know about heat transfer? We'll start with Jolie.
Heat transfer is the way the heat moves from one physical system or body to another. Heat transfer requires a difference in temperature.
Great answer. Safe, is there something you'd like to add?
There's 3 different methods of heat transfer, with conduction being a warm surface touching a cold surface and that warm surface transferring heat into that colder surface. Convection being basically where warm air would rise and cold air falls, replacing the warm air, making that's what causes wind. And radiation would be transferring heat over distances, like what the sun does to the earth.
That's right. Yusuf, is there something you'd like to add?
No.
Okay, I have a question for you. What kind of energy, so just like Miriam said, the law of energy conservation. So what kind of energy is in heat transfer?
Thermal energy.
Good job. Moving to Basin.
Radiation is how heat travels indirectly. It doesn't touch anything but the hot air. It touches it, so it makes it hot. And conduction is what makes what when we put the heat, like the fire on under the pan, so the fire usually touches, so it also makes heat in the pan. And conduction is like what they said, that the cold air comes down and comes heated up and goes back up, so it makes an upwash.
Thank you, Basil. Is there something you'd like to add, Tuta?
No thanks.
All right. Moving to the next question.
So what do you know about convection? So can someone explain to me what is convection? We can start with Yusuf.
All right, so convection is a way in which heat travels. It occurs when heat is transferred by the movement of liquids or gases. So for example, if you are boiling a pot of water, okay, the cold will go down, heat up, and then go back up. And then after it goes back up, it will cool down again, and then it will go down and heat back up. And it's a loop until the heat, until there's no heat.
Exactly. So this is occurring due to a difference in density. So the hot water, when it boils, it will become less dense, so it will rise, and the cooler, denser molecules will sink. Exactly. We can now hear from Basil. What do you know about convection?
About convection, like when I said, that the cold air coming down, so it heats up and goes back up and comes back to your sense. Hot air is lighter than cold air.
Exactly. Julie, do you want to add something?
No.
Tuta
No, thanks.
and Saif?
Convection also occurs in the oceans with water being warm near the equator and becoming colder near the poles. And these currents bring warm water near certain shores. That's why European, while yes being farther north than many places in Canada, is far warmer than Canada most of the year.
Excellent. Exactly. So convection, it refers to the form of heat transfer in which energy transition occurs within the fluid. So it mainly shows how heat passes through fluids, and it occurs due to difference in density, as Yusuf explained by giving the example of boiling water. Now we can move to the next question.
This question is about cohesion, and what do you guys know about cohesion and adhesion? Start with Jolie.
Cohesion is the process of water sticking to itself. The negative charges on oxygen stick to the positive charges on hydrogen atoms of other water molecules. Adhesion allows water to stick to other partly charged things.
Good answer. Saif, is there something you'd like to add?
Water is able to get up to a tree without it having any muscles or and anything to pump it up via branch. Via the xylem, it works up the xylem and into the tree. So that is a function of cohesion and adhesion.
Great. Yusuf, is there something you'd like to?
No.
Basil, is there something you'd like to add?
No, thanks.
Tuta?
Well, cohesion is it's like sticking of particles of the same substance. But adhesion is opposite. It's like when when particles of different substances stick together.
So cohesion is like frankly speaking, a form of sticking. It's just water particles sticking to water particles. And adhesion is another form of sticking when water can stick to other particles. Okay.
So Jumana, can I add something before we proceed?
Please go ahead.
Yes, so I want to ask you, so by now you know what is the cohesion and adhesion. So why do rain falls in droplets rather than a fine mist? Can someone answer?
Could you repeat the question, please?
Yes, so why do rain falls in droplets rather than a fine mist? So why it falls in as a droplet?
Due to cohesion in the cloud, water molecules clump up together, and once they become heavy enough, they drop out of the cloud.
Exactly, it's because of cohesion. So water has a strong cohesion, which pull its molecules tightly together, forming droplets. Yes, exactly.
Great, you guys did a great job today. Now, one last question. Have you learned something new today? You want to start the poll? Here. It was great having the young future scientists today. Thank you guys for joining us today. If you haven't already, please make sure to check out our YouTube channel and join our Facebook page, Madrasty, for the latest updates of our upcoming courses.
So thank you all for participating. I hope that you all had fun while learning about different topics in physics. Thank you, Saif, Tuta, Bassett, Julie, and Yusuf for your participation. Now I hope you all enjoy the rest of the day and see you next week, so in 2022. So by that, I wish you a happy new year. Thank you.
All right.
Before closing up, I'll leave every one of the future scientists say bye.
Bye-bye.
Bye.
All right. Goodbye.
Happy
See
New
you
Year.
next week. Happy New Year.